A look at Ford versus Ferrari with Automotive Hall of Fame inductee Clement Drummond. There's a lot of brum, brum, brum. Coming up next on Science Goes to the Movies. Welcome to Science Goes to the Movies, a look at the stories of science and how they change our culture. I'm Lisa Beth Kovitz. I'm delighted to have Clement E. Drummond, Director of Automotive Technology from CUNY's own Bronx Community College, joining us today to talk about the film Ford versus Ferrari. Clement, welcome to the show.
Thank you. It's certainly my pleasure to be here to talk to you about auto racing.
Well, let's jump right into it because I have so many questions. In the movie, in an early scene, Christian Bale's character, Kent Miles, scoffs at a foolish customer trying to drive a high-performance sports car like it's the family sedan. Now, I get why you can't drive a family sedan like a sports car, but why can't you drive a sports car like a family sedan?
Well, back in the 1960s, cars had carburetors, and they weren't very precise. So now, on a sports car like the MG, what happens is, if you drive it very slowly, it starts to build up carbon. The carbon builds up on the spark plugs, actually shorts them out, and what happens is it prevents the car from actually going down the road at a higher speed. It'll start to misfire. So what would happen is people would take their car on a Sunday afternoon on a long straightaway, and you would actually have to accelerate through each one of the gears to blow the carbon out of the engine to prevent the spark plugs from shorting out. And if you didn't do this, over a period of time, it would be required to remove the cylinder head of the engine, remove that carbon, and it was called a carbon and valve job, which you would never hear of again in this day and age.
Oh, that's crazy. So did that only apply to go-fast cars, or all cars needed to have a little boom happen to
well,
so they could...
What's interesting is today's cars can go 100,000 miles on spark plugs, and you could have to change the air filter and things like that. Back in the 60s, every 12,000 miles it was required to get a tune-up on the engine. Wow. Because the parts, like the ignition system, was mechanical. The carburetor was mechanical. Today, everything is computer controlled.
If there was an award for most shots of car dashboard gauges with the needle bleeding into the red, Ford versus Ferrari would be the clear winner. James Mangold used all his craft to build tension as Carroll Shelby's team pushed their GT40 Mark II to 7,000 RPMs. Clem, I got so worried when the car started to hit 7,000 RPMs, and I don't even know what an RPM is. Never mind why they should not go to 7,000. So what's the significance of RPMs and 7,000?
Well, RPMs are revolutions per minute, all right? And that's the measurement of the crankshaft going around. What happens is when they dyno tune the engine, they have the engine out of the car. It's on a device that actually measures the horsepower and the torque. Well, they found that if they ran the car at the RPM of the engine at 6,200 RPMs, they tested it that it could last 48 hours. That was twice the amount at Le Mans. So what happens is the red line is where you start going into the danger zone. The danger zone is where you're going to produce too much heat. That heat will cause catastrophic failure to the engine. So if you bump into the 7,000, and just for a short period of time, it's okay. But if you stay there for a long period of time, you'll have that excessive heat and cause damage to the engine.
Okay, so when he shifted down, when he shifted up, the RPMs dropped. And why? What are they doing? What are we doing when we shift that?
Well, on the transmission, first of all, the way that the transmission was specially built for that car. In 64 and 65, they weren't specially built. They had one design that it would last the 1966 race. So what happens is that was a 4-speed transmission. So in first gear, at 6,200 RPMs, the car was able to go 89 miles per hour, just in first gear. Now, second gear, the car was able to accelerate to 140 miles per hour.
We're talking about the acceleration of the GT40.
Yes, and in third gear, it would actually go up at 6,200 RPMs. It would go to 170 miles per hour, and in fourth gear, it would go to 205 miles an hour, where the Mulsanne straightaway is 3.7 miles long. Now, so that's upshifting the car to get up to speed. Now, when you get to the end of that Mulsanne speedway, and you have to the car has to go down to 50 miles an hour to negotiate the turn. What happens is, as we've seen in the movie, the brakes were glowing red hot.
Right.
So therefore, you use the advantage of the transmission to downshift, and the engine helps brake the car. So you're using the engine to actually cause resistance to actually make the car go slower.
To save the brakes.
Yes, yes. And the other thing is that when he wanted to pass somebody on the straightaway, if you notice, he would always downshift one gear. And that was to be able to get the RPM up, but you were able to get the torque by manipulation of the transmission to actually pass the car.
So he downshifts to pass so that the
yes,
torque...
so right, he could get more RPMs,
Oh.
more horsepower, because horsepower equals the torque times the RPMs. So that's how you get the power, or the power is actually the work that's being done. So
then when he would downshift to come up, and then when he upshifts, he would have all kinds of torque and already a lot of spin,
right,
from the layperson's terms,
yes,
so that he could
pass the other car.
I believe that's what we call vroom.
Yes.
In Ford versus Ferrari and in real life 1964, none of the Ford GTs completed the grueling 24-hour high-speed race that is Le Mans. But Matt Damon, as Carroll Shelby, tells John Bernthal, playing the hottest version of Lee Iacocca ever, that in spite of their failure to complete the race, Ford's GT instilled fear in Enzo Ferrari by hitting 218 miles per hour. And 218 miles per hour in 1964 was pretty good, considering the all-time race record speed at Le Mans is 253 miles per hour, recorded in 1988 in a turbocharged Peugeot PRV V6 engine that died soon after hitting that speed. What happens to a car engine when it hits speeds at 200 miles per hour?
Well, it's not too much the engine. It has to do with the aerodynamics of the vehicle.
Oh.
What happens is, there were scenes in the movie where they showed you putting wool on the car.
We're going to talk about that.
But in reality, Ford engineers had a wind tunnel. So what happens is, there's a little piece on the back of the car called a spoiler. That spoiler keeps the back of the car down. It's a downforce. If you have too much downforce, you cannot achieve the 218 miles per hour. So it's very critical, and it only takes 1/8 of an inch increments when you're adjusting that to get the proper downforce, that you don't lose the speed on the straightaway. In addition, there's a scene in the movie where we see Ken Miles working in the garage, and he has little wedges that would fit under a door that he's going to insert into the spring of the suspension. What happens is, the technical crew, they measure the height of the car. As we know, it's a GT40 because it's 40 inches tall. But also in the front, the height of the nose of the car has to be within a specification. So what happened was, the lower the nose you can make it, it keeps the front down when you're at 218 miles an hour. If you hit a little pebble, it'll lift the car, and the air can get under it and make it raise, which makes the steering very, very light, and the car can go out of control. So what he did was, he took wooden wedges and he put them in the spring, all right? It raised the car up during the technical inspection, but soon as the car left the pits and it hit a couple of bumps, those wedges came out, and the nose of the car was actually lowered. So he was able to hold better steering at the 218 miles per hour.
What do you think, as a professional, about Le Mans and Daytona 500?
Well, that's interesting, because I always felt that Daytona because the fact is you're making left turns. All right. Yes, you're up at 180 miles an hour making a left turn around the track.
Right.
But in America, that's the Super Bowl of auto racing.
Yeah.
Le Mans is the crown jewel of international sports car racing. It's a crown jewel and it's international. So they're two different venues.
And you think it's because of the track, because Daytona is just around, and
Right.
Le Mans is
Turns, S-turns, going through country roads.
street driving.
Yes.
That's fascinating. So what breaks down a race car? Is it the same thing that breaks down a regular car, or is it what is it? What is it, the heat? Is it the jiggling?
Well, that's a good question, because if you think of the American Automobile Club of America, it's flat tires and batteries going dead. That's their biggest service call. When it's on a race car, it has to do with heat. The heat, the more combustion you make, the more heat you make. The further you go up to that red line, the more heat. Once you get into that red line and you stay there, you could actually melt the engine. So I would say heat, suspension, and tires are probably for the race car.
In the movie, there's a brief scene in the 1960 Ferrari factory where they're hand building automotive engines. Can somebody actually build a car engine by hand?
Today,
I mean, these days, can somebody actually build
these days you can build engines by hand. I mean, there's nothing wrong with it. I mean, the fact is that most engines today that are built at a factory are done by robots, and it's very precise. They take pictures of the robot, and this way, if there's ever a defect, they go back to that day, that moment in time. Hand-built engines, it's time-consuming,
Right.
but it's done to perfection, human perfection, right? And at the college, we have an engine that's hand-built. We have a Cobra, and basically we got an engine from Ford SVT, which is Special Vehicle Team, and they built all the engines by hand. So on the engine, there's actually a plate that actually says who built that engine and put it all together.
Wow.
Yeah.
Well, so as a teacher at Bronx Community College, what do you think your kids get from what do you think your students get from hand building an engine?
Well, first of all, we do have a class called engine repair. Engine repair is where they disassemble a complete engine, and they have to learn how to measure the engine and return it back to specification. So it's the fact of not only being able to disassemble an engine, but to find out what went wrong with the engine.
Right.
So that has to do with all measurements. So they learn torque wrenches, they learn how to use, actually we have, at the college we have a complete computer lab that you can look up all the specifications before time, and then you measure it and you compare to what you have in that engine and what needs to be done.
So what does it mean that the breakdown of the engine has to do with measurements? That's fascinating.
Yes, really a technician's job is to return it to its original operating. So in other words, return it to original specifications.
And the specifications have to do with the relationship of size from one piece to another thing?
Yes, because as it wears, the part actually gets smaller. Say if it's piston
Oh.
rings, so we'll say that there's an end gap of 10 thousandths. Well, as it wears, that gap gets larger. So in other words, if we put new piston rings in, they would be actually, the gap would be the 10 thousandths again.
And what kind of measurements are we talking about? We're talking about hundredth of an inch?
Thousandths of an inch.
Wow. Wow. The Mustang was, and still is, a big deal for Ford, and in the movie, Ken Miles hates it. Did the Mustang deserve his rage, or was it just not a sports car?
Well, what happens is the original Mustangs had a six-cylinder engine in it. And to Ken Miles, this is their words, not mine. It was a car designed for secretaries. That's what he said. And what happens is, until they decided to make it into a V8, all right, and that's where the 289 came in, and that's where it started to make its transition that it could be more than just a daily cruiser, that it could actually become a sports car. But a sports car only had 2 seats. And that was the part that Carroll Shelby would always say, but it's not a sports car because it has 4 seats.
In the movie, once Shelby American is in charge of developing the GT, Miles and Shelby use Scotch tape and pieces of string instead of a giant aeronautic computer to gauge wind drag on their car. It's a fun scene, but all historic reports say Shelby's team welcomed input from Ford's computers and aeronautic engineers. But nowadays, are computers simply inseparable from automotive mechanics, and how does that affect your program?
Well, one of the things is all cars produced today have onboard computers. They could have as many as 30. And what happens is they all talk to each other. So students have to first learn the foundation. We have to build a foundation of knowing how something works. The first thing everybody wants to do is plug in a scanner and it'll come up with codes. But it could be something as simple as not enough coolant. All right, so now the engine's running hot, so the sensors will read a little bit different, and it'll set a check engine light. So, I mean, if you don't check the basic engine integrity of does the cooling system, is it working? Is the fact, does it have engine oil in it? All right, and all these different things will affect how the computer reads the engine. So it has various sensors around the engine. We measure the oxygen in the exhaust. We measure the engine temperature. We measure how much air is going into the engine. Then we match the fuel. And then what happens is there's oxygen sensors all around the exhaust system to compare. And what happens is the computer's communicating with that. Now, what happens when you bring your car in for service? You got to check engine light. Yes, we are going to scan it to see what the code is. It sets us in a direction, but you still have to have an understanding of how various components of the car actually function. We have a class called ACS 38, and students get 6 hours a week of hands-on training of diagnostic with computers with late model cars. We happen to be part of the Nissan Technical Training Academy. So we are certified by Nissan. Nissan gave us brand new cars. We have actually a 2019 Infiniti QX50. The car costs $54,000. Well, we have the new technology that the students are learning on. Not only that, if they want to go into an internship, we have that available to them also. They have to take 12 modules that are CBT, computer-based training, and then they can go into the dealership and work part-time. And it's great because for the simple reason, you're learning in the classroom, but you're applying it and they give you a mentor, so this way you learn the correct way.
So computers are making it at the same time more challenging and more directed, would you say?
Actually more directed.
More directed.
Right. I think it's a lot easier to find out or diagnose a car today with the aid of a scanner to communicate to the computer. And actually, if you had to go for a road test, what happens is we can put a data logger onto the car, and if it does have that little skip or hesitation, that will be recorded, and it's just like going into an EKG and watching the different patterns.
Well, it was interesting in the movie, when they pulled that computer out, they were so concerned about it being heavy. What's the relationship of size and weight to speed?
Okay. Well, weight, the more weight you have, the more horsepower you're going to need. So if you can have high horsepower and a light car, like the Cobra's approximately 2,000 pounds, all right? So now you have 485 horsepower and you have a light car, you can go very fast.
You know, Clem, a friend of mine who's a huge fan of GTs, told me that, he said that the GT is one with the body. What did he mean by that?
Well, okay, race cars, they're two different types. If it's a NASCAR, it's always a tube-type chassis, all right? And one of the things is on the GT40, it has a monocoque chassis, which basically means that the chassis and the body are integral. And what happens is it's good for a safety feature in the sense that it protects the driver. So when you're going, if it did get in a crash, the survival would be greater in the GT40 than a drag racing or a NASCAR, which is more like tubing,
Interesting.
especially at 200 miles an hour.
Yeah, yeah. Before the timeline of the movie starts, Carroll Shelby put an American V8 engine into a race car to create the AC Cobra, powered by Ford's 4.2-liter V8. Why was a V8 in a sports car something so remarkable?
Well, most of the sports cars at that time were only about 100 to 120 horsepower. All right, they were four-cylinder engines. They were nice, but they really weren't that fast. But now, putting a V8 in, so now we got 200 horsepower,
Wow.
more torque. And what happens is he was able to fit the 289 engine into the AC Cobra, and that made it an exceptional car. The reason why he didn't really want to put a 427 in the Cobra, although he did at a later date, was the agility of the car, the handling of the car. The weight was perfect for that V8. It wasn't overly heavy. When you start going up to the 427, it weighed like 500 pounds, where this was a small V8, nice little package that fit perfectly into the car.
So it wasn't just the idea, it was actually, there was a great deal of engineering around getting that idea to work.
Yes, he actually contacted the car company that built that, AC, and what he asked is would be willing to build the body and design it exactly for a V8.
Shelby's AC Cobra did not win at Le Mans. An American car had never won at Le Mans until Shelby American raced the Ford GT Mark II. So I would like to talk about that car. What is so special about a Ford GT?
Well, first of all, the Ford GT. Actually, the GT is Gran Turismo, all right, which means fast car. It's 40 inches high, all right, that's part of the specifications. It has a 427 engine in it with 485 horsepower. It had 475 foot-pounds of pound-feet of torque at 4,000 RPMs. So the engine and matching this whole product together. First of all, the tires were very important because the other cars that were in the race in 1966, they had Firestones, and they had to change in the middle of the race to Goodyears. So Goodyear tires were actually the ones that were actually on the car when they won. The other thing is that they had to have a special gearbox made. The transmission, it wasn't the same transmission that they used in the 64 and 65. Same thing with the differential, was built by a special manufacturer. And the big thing was they had stamped on it GT40, okay, but it was embossed. But basically it was the combination. But the whole thing is, it really had to do with Ken Miles. Ken Miles did the actual engineering as far as the drivability part. Yes, Ford packaged many of the parts. There was an engineer just for the engine. But what happens is, it was actually when somebody took the car actually on the track, and we said the seat of the pants driver, right? He could feel what needed to be tightened up, what needed to be loosened up, how to get the nose down low enough that you could go that 200 miles an hour.
Right, that's fascinating, that it really was the experience of the man and car that we saw in the movie.
Right.
I mean, like, I never really understood how much numbers play into automotive mechanics until I'm sitting here talking to you and hearing all these numbers come at me. And it really is a very much the measurement and the numbers that go into automotive mechanics is just amazing.
Well, one of the things is today on the new cars, everything is done with computers talking to computers.
Right.
All right. So when you're driving down the road, there's a body computer, there's an engine computer, and what happens is that's what makes the driving experience today. Today, the steering is electric. Most people don't know it. The steering is electric on your car. It's not anymore. there's actually a little motor. So when you're turning something, the motor down on the bottom is actually turning the steering.
Oh.
Yeah, so it's quite interesting. And today, you know, the car could stop itself. Think of
Right.
it. You know, you're going down the highway, all you do is press a button, and it'll track the car in front of you at a safe distance. As the car in front of you slows down, your car will slow down. And if it comes to a complete stop, it'll stop the car. And if the traffic the traffic starts moving again, the car will take off by itself again and come right back up to the speed limit.
Well, all that is great for safety, but I really now see that this movie is really about a moment in time when it was very different to drive a car.
Most certainly, because everything was manual.
Yeah.
I mean, the engine, all the components, all right, there was no computer on board to change the parameters.
Right.
Either you had it right or it didn't work.
Clem, we are out of time. It has been such a pleasure talking to you.
And you know something? I enjoyed myself. It's great to talk about something that I have passion for. And, you know, and to talk about what we do at the Bronx Community College Automotive Technology program. Thank you very much.
It's been such a pleasure.